The last way of escalating privileges that I want to talk about is using capabilities. If you're interested in learning more about capabilities and the specifics of how they work and where they're applied, I highly recommend checking out the hack tricks page on Linux capabilities. So you could always Google Linux capabilities hack tricks, and you'll find this page here, where at the beginning they talk about the different kinds of capabilities, or I suppose the different capability sets. Then it talks about what they are and where they can be applied, and at the end, you have a list of a bunch of different capabilities that can be abused. So, what is a capability? Well, as it says here, Linux capabilities divide root privileges into smaller, distinct units, allowing processes to have a subset of privileges. So, every single process in Linux has a specific set of capabilities, and these capabilities define what that process can do. In addition to processes having capabilities, you can also set capabilities on files. When you set a capability on a file, then whenever somebody runs that file and creates a process, that process will have those capabilities. So for example, if I give a file the setuid capability, then whenever I run that file, the process that file runs as is going to have the setuid capability. I actually want to make a big distinction between capabilities and file attributes. So let's take a look at setuid. With the setuid capability, it says it's possible to set the effective user ID of the created process. The key word is of the created process. So if you remember in previous examples, that setuid bit allowed us to run that file as the owner of the file. The setuid capability, if that's set on a file, that doesn't necessarily mean that when we run that file, it'll run as the owner of the file. No, it'll still run as us, right? However, this setuid capability allows that process that we start by running that file to then change its user ID. So just wanted to make that quick distinction there. Point is, files have capabilities. Basically, capabilities on files just means that when you run that file, the process that runs that file is going to have this capability, and capability is essentially something that process can then do. We can actually read all the file capabilities in Linux by using getcap. If I say getcap -r and then slash will tell it to look for all the capabilities for all the files on the file system. However, in this case, it says command not found. The reason for this is perhaps that command is not in my path. So I'm going to have to look around a bit to figure out where that getcap command is located. So I'll say find / to search the file system. I'll search for a file name, and the name I'll search for is getcap. Again, I'll redirect any errors to dev null. Now you'll notice that this file is located in user sbin getcap. I'm guessing that user sbin is probably not going to be in my path, and that's why I couldn't just run it as a command when I tried to do that here. If I say echo path to check that out, $path, you'll notice user sbin is in fact nowhere in my path, and that's why that didn't work. Anyway, I can use the full path to getcap, and then run that command. And now you'll see that we have two files that have special capabilities assigned to them. Capabilities aren't necessarily a bad thing. In fact, ping needs this capnet raw capability in order to function, because ping uses ICMP echo. By default, if you want to send network traffic or raw traffic like an ICMP echo, you need root privileges in order to do that. However, this capability gives ping the ability to send that traffic even when somebody who's a non-root user runs ping. So that's what allows ping to work. However, we see this other one here, we see chown has the chown capability. Let's dig into that a little bit further. If I go back to that hack tricks page and I look at the chown capability, cap chown, it says this means that it's possible to change the ownership of any file. The keyword here is any. So not only can we change the ownership of files that we own, but we can also change the ownership of other files on the machine. So knowing this, and knowing that we can use the chown utility to change the ownership of any other file, how can we use this to escalate privileges? Well, we can change the ownership of another potentially sensitive file right to that file and use that to escalate privileges. The example I'll use here is I'll actually change the ownership of the etc sudoers file. I'll add a line there that lets me use sudo, and then I'll use that to get root. So to demonstrate that, let's use chown, and actually let's look at the current permissions of that etc sudoers file so I can always set it back afterwards. So if I say ls/lah etc sudoers, you'll notice it's only readable and only by root. Okay, so we'll have to do a couple of things. First of all, we can change that file ownership so that we are owners of that file. So if I say chown hacker etc sudoers, now we are the owners of the etc sudoers file. The second thing that I'm going to need to change if I want to be able to write to it is I'm going to want to give myself write access to that file. So I'll say, now that I'm the owner, I can change the access that I have as the owner to that file. So if I say chmod, and let's just say 42, so 6640 etc sudoers. Now I gave myself that write access to that file. So now that means I can edit the sudoers file. The safe way of editing it would be with vsudo, but I'm actually just going to edit it with nano. I'm an attacker. I know what I'm doing. I don't really care. So I'm going to say nano etc sudoers. And it's warning me that the directory etc is not writable, but that's fine because etc sudoers is. So I can actually go down here and I can add myself as a sudoer. So I'll just add it right down here. I'll say hacker. I'll say all equals all. Now the one additional thing I'm going to add is I'm actually going to say no password. So then I don't even need to know hacker's password in order to use sudo as hacker. So if I save that out, and now if I try to use sudo as hacker, if I do sudo-l, you'll notice that it gets mad at me because it says sudoers is owned by the wrong user. It should be owned by root. But that's totally fine because we can just change it back, right? So if we say chmod 440, which is what it was originally set to, and then we need to change the owner, so chown root etc sudoers. Now it's back to the way it originally looked. And now if we run sudo-l, now we see that user hacker may run the following commands on Debian. We can run any command as any user. So I can simply switch to root by saying sudo su. Boom, now I'm root. If I say who am I, you see that I am root. So where did this vulnerability actually come from? It actually originally came from, this is an example of multiple steps being taken in order to exploit the vulnerability, but the original vulnerability was because of that capability set on the chown file, right? So how can we fix that as defenders? I'm just going to clear all this out. So as defenders, we can list capabilities just as an attacker would. So if I say get cap -r/, I'll run it with sudo. We see those same capabilities that we saw before. I can remove a capability by saying sudo setcap -r for remove, and then the path to the file that I want to remove capabilities from. So in this case, user bin chown. Again, I want to caution you against doing this, because if you remove a capability that's actually necessary, you could potentially disrupt a service or how Linux is supposed to function. So for example, ping needs that capnet raw capability in order to function, and if we were to remove that, then normal users would not be able to ping other machines. In this case, I did my research. I know that chown should not have the chown capability, so I'm going to go ahead and remove that. If I list capabilities again, now we only see ping, we don't see chown anymore. And if I switch to user hacker, and I again try to modify the etc sudoers file, or try to change the ownership, I should say. So I can say chown, hacker, etc sudoers. You'll notice now it says operation not permitted for changing the ownership of etc sudoers, so we fixed that vulnerability. I'm probably also going to want to remove hacker from the sudoers file. Remember, hacker added themselves to the sudoers file, and that's how they abused this to finally get root. So if I say sudo vsudo abc123, and then you go down to where hacker added themselves. Again, I can remove this line, or if I'm not entirely sure if it was a hacker that added it or an attacker, and maybe it was maybe it's supposed to be there, I'm not sure. I could always comment it out, and then I could always come back later and uncomment it if it is in fact supposed to be there. But in this case, I know the hacker added it. It's not supposed to be there. I'm going to remove that line, write that out. And now, if we switch to user hacker and try to see what hacker can do with sudo, again, user hacker can no longer run sudo.